Hi, welcome everybody. This is Nav Mathur with Neo4j, and welcome everybody from around the world, I guess. So good evening, good morning, wherever you are. And I want to just also talk about CluedIn. CluedIn is a partner of Neo4j. And Tim Ward is the CEO at CluedIn, and very excited to be here with him doing this webinar on GDPR. So without further ado, let's get into it. So the agenda for today is talking about how GDPR will impact your business. So just a really quick introduction to GDPR for those who are maybe new to this, but most everybody I'm guessing is well aware of this regulation and what is required. So we'll talk about personal data tracking and what is involved in doing that, and then talk about why graph databases are the right GDPR solution or foundation, and then get into the CluedIn aspects of this and their solution, and Tim will take us through that. And he will also give us a solution demo as well. And then I will wrap it up with the concept of a minimal viable solution. I think a lot of folks are struggling with this at the moment as to what exactly they should be implementing to get by, to squeak by the regulation when it becomes law in May next year. And then talk about next steps. So, talking about how GDPR will impact your business, there are obviously a lot of scaremongering going on around with the fines that are being talked about, which are pretty hefty. There's also a lot of personal liability that is being talked about. There's actually a bill right now, the Digital Economy Bill in UK's Parliament that is proposing that company directors may become personally liable for the payment of fines. And so there's a lot of personal liability that may come in here. And that is scaring off a lot of executives at companies. But aside of all that, I think one of the key things here is that the accountability for companies is definitely increasing. It has been increasing, but with this law now, it's here and now. And then the regulatory leeway in terms of gray areas of the law is decreasing. So and also you cannot really pass the buck to cloud providers who may be hosting your data and providing the service back to you. You're still accountable for this data, this personal data. And so there's already been a lot of examples of fines that especially the larger firms have incurred or have the data authorities in different regions have imposed these fines on Google. The latest example of this was Facebook in Spain, where the Spanish Data Protection Authority called Facebook out for tracking people's ideologies, religious beliefs, personal tastes, and sexual preferences, and things like that, illegally. By getting third-party data and data that they had on people without clear consent. And I think that's the key aspect of this, is they did not have clear consent, and also they did not specify how they were going to use this data. I think these are the two key elements that brought together this fine of 1.2 billion euros for Facebook in Spain. Of course, they're fighting it, but the point of it is that this is already happening, and a lot of people would argue that, oh, they're just going to make examples out of these large firms, and it will not really affect us in the near future. and let's wait and watch and see what happens. And I think it's not only these large firms, but there are several examples of smaller companies also facing these fines. And I think it is just a simple. At the moment this becomes law, it's just going to be a simple a request or a letter from your local authority asking you to just explain how you're compliant, and that's all it takes to get the ball rolling from their side. And so I think clearly something has to be done in order to be compliant, and hopefully what we will show you today is what is the most straightforward and way towards a solution for GDPR. So with that, let's talk about what aspects of GDPR really kind of conform to this solution that I've been talking about. We have tried to make it pretty straightforward and simple for you. We sort of have this grid which talks about what data do you have, what's the personal data do you have on the subjects, have you clearly identified what that data is, where is this data stored, in which system, in which application, do you have a clear understanding of that, and over time, how does this data move from system to system as this subject is more ingrained in they go from somebody you market to they become a customer to as they progress from a process perspective within your organization. How and when did you obtain this data? Do you have a clear understanding of how you got this data? From where did you get this data? And then why do you have the data? What are you using it for? What purpose? What is the usage? And who in your organization has access to that data, to this personal data? And do you have permission to use that data? Do you have the consent? Do you have the consent for a specific purpose? Is this data secure where it is being stored and how it's moving from place to place? And how does this data travel through your systems? And does the data ever cross international borders? I think this is another key one where I think you have to clearly put in the GDPR register where the data is crossing EU boundaries. So I think these are the key aspects of GDPR and what you need to really record from a register perspective. Register is a key requirement of GDPR in Article 30. So the burden of proof is on your organization, and how do you sort of solve for that, right? And so this is employing the right technology is definitely going to be key to having a most cost-effective solution for GDPR. There are a lot of consultants going around, large systems integrators and large consulting firms that are charging quite a packet in terms of the process consulting and kind of understanding the requirements to building a solution and then customizing that and all of that. And I think you can avoid all of that. There are clearly some process areas that you need to address, but so is having the right technology solution. There are a lot of solutions out there. Everybody is touting a GDPR solution today. And so it is very difficult to sort through all the different kind of solutions available. But generally speaking, there's a lot of solutions that are cobbled together. People that offer already products in areas around data governance, and compliance are scrambling to put something together. And generally speaking, they are bringing together 3 or 4 different products that they already have together with some consulting to put it together. There's also a lot of products, you know, that are or a lot of organizations that have a good understanding of what GDPR requires, but have traditional technologies that they're bringing to bear here. You know, I think each comes with their own angle. But hopefully what we will show you is that this is a lot about connected data. So it's a lot about connecting your subjects, you know, the actual people here, as they're called subjects in EU terminology, connecting the subjects to the location in which the data is stored, to the application or the system where the data is stored, to the users that access this data, to the consent that these subjects provide, and for the purpose or usage that you have this data for, and so on and so forth. All of these kind of entities need to be connected together to kind of create a solution. And that connectedness is something that a graph database is the right foundation for. And one of the key aspects of what a data protection authority will require is data lineage. And what data lineage means is that how can you prove to me that this data that you have for the subject, are you clear about when and where did you obtain it? Are you clear about how it has traversed through your systems, who has had access, and when, and how are you eventually using this data? So are you able to show me that whole lineage so that I know that you are tracking this information in the register, and that, you know, you can prove yourself to be trustworthy to hold this data. This is something that a subject may ask as well. And so that showing that data lineage in a visual way is one of the key aspects of the solution, and that is enabled by graphs. So without further ado, I want to introduce Tim Ward from CluedIn, who's going to talk more about the details of the solution. So Tim, take it away, please.
Yeah, sure. If you could just make me the presenter, Nav, that would be great. I'll share my screen.
Absolutely.
Excellent. Well, thank you for that introduction, Nav, and thank you everyone for joining this webinar. I'll give you a little bit of context. We are CluedIn is a company based out of Copenhagen, Denmark. We've been working in the GDPR space for some time now, and a lot of the kind of themes, the general themes that we're kind of hearing from our customers right now and future lifetime customers is that they're getting a little bit sick of the GDPR. Now, one of the interesting and what I think is the best parts about the updates to this regulation have been around the focus that companies have been placing on privacy, on security, on data breaches, and just a general training around how do companies work with the data that sits within their dispersed company environment. And essentially, we're kind of, I guess, from a product perspective, combined with the technology stack of Neo4j, solving this for our customers. So at CluedIn, essentially what we do is we are a data integration platform. The reason we exist is because taking a look at the average company, they use anywhere from 50 to 150 different tools to solve common workplace problems like sending mail, like setting up events, accounting, invoicing, project management, customer management. Of course, you can imagine the list just goes on and on. Now, we in CluedIn have seen a huge explosion in the adoption rate of new tools within companies. And we saw this as kind of a way of looking at the common status quo of data integration platforms now, and quite the manual and tedious approach that usually involves integration projects, and turning it on its head. So in fact, CluedIn takes quite an automatic approach to data integration. We require no downloads. We don't require engineers. We are very much a plug-and-play system for integrating tools that exist within most companies today. And so I think when Nav highlighted these 9 high-level boxes of what a company needs to do to be able to kind of meet this minimum viable product for being compliant and being able to process requests come May 2018, I think it's a really good high-level bird's eye view of what needs to be done. If we take a look at the regulation, it's 154 pages, so there's obviously a lot more detail and finesse to each of these points. But at a high level, I think Neo4j have done a fantastic job at kind of identifying the high-level points of what we should look for in a technical solution for being as compliant as possible coming May 2018. So based off our customers' feedback, based off the companies that we're talking to in the EU, there's this general theme of there's enough talk. We've been through the process, we've got the advice, and now we're looking for a solution that we can start processing requests tomorrow. The idea being when May 2018 comes, those companies can be overly confident that exporting the data to the individuals that request it is something that's not an unknown. It's not something that's going to be unforeseen. It's something that they have a lot of practice with, and they've built up this confidence in their technology stack. When we talk about GDPR, usually break it up into 5 different pipeline steps, and it's important to note that all of these steps are still very valid and important. So most of the companies that we talk to are actually right now in the process phase, in that they've got the advice from their internal legal groups or external consultants. Now they're going and implementing the processes in the different departments of how they will physically not only work with their current data, but be able to facilitate these requests come May 2018. Now, CluedIn, we focus on the technical solutions, so that's where I'll be focusing today. But I also wanted to touch on the fact that there's also training and validation that comes after these steps. The training is mainly not only from the training individuals on how to use the technical solution, but also to make internal staff much more aware of the importance of privacy and data in the common day. From a validation step, this is actually when we're consulting with a lot of our customers and finalizing their GDPR solution. This is actually one of those steps that is often missed, i.e., what is a company required to actually export in these reports? And how do they validate that they're not sending out potentially other private information about other individuals in their exports? So we're going to cover the technical solution side of these things that at CluedIn we help out with a lot of these different stages to automate this process. So let's go back to fundamentals. We have a very similar vision with Neo4j in that we want to build the connected enterprise. And like Neo4j, it's all about one single idea, and that is you need a uniform way, one single way to get access to your data. And that is connected data. And the fundamentals allows companies to be able to move into areas like data-driven businesses, like being in the connected enterprise. Now, one of the coincidences behind this is that if a company was to go back to basics, go back to square one, and design a technical solution that could help process requests for the GDPR, it just so happens that having all your data in one place, connected, enriched, cleaned, and validated, is the exact same technical solution that you would provide today. So why now? Master data management, or connection of data, or building the connected enterprise is something that companies have been wanting to do for 30 to 40 years. And there have been some fundamental shifts in technology that have allowed us to be able to increase the precision of solving something like automatically connecting data between different systems, especially when it comes to connecting data around individuals. Let's start with the technologies. There are 2 fundamental technologies that have allowed platforms like CluedIn to increase the precision of us being able to produce solutions for GDPR. The first is obviously the graph, and for us, that's Neo4j. One of the fundamental game-changing ideas behind the graph is its actual data structure. And for us, it all revolves around its innate way to store context. When it comes to figuring out and analyzing data from discrete, ambiguous systems, it could be noise, it could be extremely valid. Using the graph, once the data is stored in a connected way, one of the most important things is that every single thing surrounding an individual is saved in context. We know what documents are connected to them. We know what mail is connected to them. What this allows us to do as a data integration platform is that when we're pulling information out of the graph and processing it in our processing servers, whatever decisions we make in those processing servers, when we persist it back to the graph, it has a natural data structure, a natural data store to be able to maintain context. This is something that your traditional relational database or document-based store or search index, although could be bent into doing this type of thing, was not designed from the ground up to solve this type of problem. Now, the next technology is machine learning. And from machine learning, you could categorize as a topic. At CluedIn, we'd like to categorize it as new engineering techniques. Now, machine learning is not the silver bullet. It's not something that has turned this knob from not solved to solved. But what it has done is it's increased our ability as engineers to be able to increase the precision of us connecting data and inferring relationships between data in an automatic way. Now, it goes without saying that when it comes to APIs, it's very uncommon today for most products, especially SaaS products, to be released without an API. In fact, most of the pivotal companies that brought SaaS into the world started off with this idea and propelled this idea of when a company is using a tool, the data that they put into that product is their data. They have the right to be able to get that data out, to post new data into it, to be able to feed it into other systems in a very easy way. Now, when it comes to solving the problem of GDPR from a technical perspective, this makes the problem just that much easier to solve. You do not see a lot of products released today that are released without the ability for platforms like us to get access to the data and therefore use that information to try and make sense and potentially connect it to individuals. In the end, this all comes down to the business value of being able to find every single thing your company knows about an individual in one single place. It also goes without saying that with technology has come the ability that most technologies these days are low cost. Now, what this means is that for having a GDPR solution and a data integration platform, this is now something that not only the big enterprises and big large companies can afford. In fact, utilizing technologies like Neo4j, it allows even the smallest of small companies and startups to have a very viable GDPR solution without the huge price tags. Finally, I'm going to go into detail on the machine learning part of things. What I'm wanting to highlight is that machine learning is not the answer to solving the problem behind making sense of structured and unstructured data, which of course is one of the big parts of solving this regulation update. But let me give you a little bit of information from our production customers. I'll give you a real example. So one of the parts of the regulation is the ability to be able to identify individuals within image. So what we call this in the machine learning space is image object detection or image object recognition. Now at CluedIn, we use a couple of different libraries to solve this, which allows you to search for an individual and find images that they're contained within your company's data. One of those libraries is called Torch. And Torch is a C++ library that allows you to train models and train data sets to be able to detect objects within images. Now, when I place my image from myself at my brother's wedding, it comes up with some really interesting results. Well, first of all, it comes up with the fact that it's detected 92% suit, 5% bow tie, and 2% a penguin. Now, the skeptics in the webinar would say, okay, that's done a relatively good job, but then I would question, why didn't it say glasses? Why didn't it say male? Why didn't it say hair? Why didn't it say something else? And you'd be right to be a skeptic, because machine learning is all about solving certain problems to a certain precision. So when we place a picture of our CTO at CluedIn, who looks like your typical Viking, Nordic Viking out of Denmark, Copenhagen, Denmark, with a long beard and long hair, of course, it categorized him as a fur coat. So what I'm trying to highlight here is that machine learning doesn't solve the problem that's necessary to solve a technical solution for GDPR, but rather it can be used to facilitate in combination with existing techniques that have existed for 30 or 40 years in text processing and classical master data management to give you a true automatic unified view of an individual. So then why is this problem hard to solve from a technical solution? Well, first of all, at CluedIn, we kind of like to think that the GDPR and the regulation and the technical solutions behind it is one of the true first practical use cases of machine learning being applied to structured and unstructured data that could have huge impacts on the operation of a business. Now, of course, these techniques are great for adding value to existing products. Just the ability to add image object detection to a enterprise search feature, it seems like a lot of value. But when it comes to the regulation, the impacts and the potential fines that Nav highlighted, that's where it really impacts the bottom line of the operations of the business. Now, the next reason it's hard is because, unlike our brains, most databases that we're used to using as engineers aren't really designed to solve this type of problem. And of course, the data structure that sits behind Neo4j gives us the ability to connect data in a way that really allows us to infer relationships and to be able to find the similarities between data that could sit in completely discrete systems. And finally, the reason why this is hard, and in a way this is quite ironic, in that most companies that we work with right now are in the middle, or in fact at the end of their big data era. And I guess the irony of this is that companies have been told by the market to collect data, every single piece of data they could possibly have from all the analytics systems. And to be honest, most of the companies that we're talking to, for a long time, that data has been laying dormant. The irony being that now this data could be their biggest liability when it comes to the regulation updates. Now, to go into the specific reasons why CluedIn takes a particular machine learning first driven approach to solving the problem and providing a technical solution to give a unified view, I wanted to highlight a couple of the techniques we use that allow us to kind of give the biggest precision level of being able to identify users. The first is called entity reconciliation. And this combines a couple of different techniques that fall inside the machine learning space. And first of all, one is called natural language processing. Essentially, this describes the idea of being able to make sense or structure out of unstructured text or unstructured documents. And this could typically be Word documents, it could be presentations, it could be chat, it could be discussions that you're having. There's no real structure that's easily given to us from these different discrete systems. The next thing is pattern matching in the graph. Now, one of the fantastic things that the graph, and especially Neo4j, allows us, if it gives us a technique to be able to look at the data around an individual. And that data could be connected directly or indirectly. What this allows us to do is to be able to find patterns in how data is connected to even offer a higher precision when we're trying to identify every piece of data in an organization that could relate to or completely identify an individual. The final 2 points is that to solve this problem, it's not a black or white solution. It's about statistics. It's about having a solution that can be very statistically confident that the decisions that we're making on connecting data between 2 different systems is obvious enough that there is some type of inference there. And finally, and I've talked about this before, but I just want to reiterate it. The idea behind graph databases and Neo4j's data structure is that context is maintained within the database. When we need to do certain types of algorithms or certain types of functions to be able to figure out what is this data we're looking at, context is so important to get these solutions. So let's have a look at a classic problem. Let's look at entity reconciliation. Entity reconciliation is the idea of taking discrete pieces of information from different systems. This could be your CRM, it could be your support portal, it could be a project management tool, it could be an online form registration tool. It's about taking the data from all of these different systems and trying to boil it down or consolidate it into related data, i.e. in this example, entity 1, 2, and 5 all refer to actually the same entity or the same individual. Now, they could have different names, they could have different email addresses, they could have different phone numbers, but essentially they all refer to the same individual. Now, the way that CluedIn solves this is in a very similar approach. We have integrations that go out to your different SaaS providers and on-premise installations. We pull the data from those different systems and we go through an entity reconciliation process. Now, one of those entities could look something like this, where you've got a name, you've got a first name, you've got a couple of nicknames, and something that's, you know, potentially very clean, and there's not a lot of personal identification information here, such as an email address or a phone number. Now, here are some other examples of something that could be a little bit more verbose. On the right-hand side, you might get something from a system that is completely unidentifiable. This is the status quo. This is just the base fact that most companies have data in different systems that look like this. So this is where machine learning comes in extremely handy. You can imagine that one way of solving this, and one way that it was typically solved, is to take different combinations, i.e. if a person's first name and last name is the same, if their date of birth is the same, and if they work at the same company. Well, let's say 77% chance these people are actually the same person. This is where machine learning comes in. This is where machine learning flips this on its head. Instead, we use a function called the random forest. What this allows us to do is it allows us to tell an algorithm, here is a whole bunch of people that should be merged, and here is a whole bunch of people that should not be merged. What the algorithm does is it reverse engineers all the different combinations of property overlaps that would typically result in 2 people being merged into one single individual node within the graph. And of course, catering for common things like spelling mistakes, things like abbreviations, things like names mentioned in different orders. It's also worth mentioning that the way to solve this changes from the different countries and the different languages. So a solution that can provide a GDPR solution for extracting individuals out of raw text in Denmark differs very much from English-speaking countries or Chinese-speaking countries. So after all of this, when we talk to most of our customers, they're after a practical solution. And this practical solution essentially boils down to one question. I need to be able to look up an individual via all known identifiers and have one place where I can export their data within minutes. And before I show you what this looks like with CluedIn, the CluedIn mission is essentially is summed up in one kind of discrete sentence. That is that we at CluedIn want you to get back to work. We want you to get back to the products that you're building, to the databases that you're improving, to the services that you're offering. And the way we do this is that we are a turnkey integration, i.e. we have over 100 plus out-of-the-box integrations into the most common of tools that companies are using today, ranging from CRMs to project management tools to support tools, even enterprise tools like Salesforce, Dynamics. Depending if it's on-premise or not an issue at all. We have the support for you. So in fact, we can have companies up and running on CluedIn, backed by the power of Neo4j within minutes, instead of huge, tedious integration projects. So let's have a look at what this looks like. What I'm going to do is I'm going to use an example that I'm hoping most people on this call will have some context around. And that is looking up an individual, which is the CEO of Neo4j. Now, for those who know Neo4j, you'll know that the CEO of that company is Emil Efrem. Now, here we have CluedIn, where we've plugged in all the different tools that we're using within our environment. Now, all it's a matter of is looking up Emil through in the system. And what's most important is that we have one individual record where what we call the unified view. Now, this unified view gives us pointers to every single piece of data based off our internal tools that we know about Emil in one single place. Now, what's also important is that through the request, it's required to identify an individual as themselves. So you can ask that individual requests like, can you confirm your email address? Can you confirm your phone number? It's important, therefore, that for very common names like my own, Tim Ward, it's most likely that you could have two or many Tim Wards within your personal or your company's data. So it's so important that you're able to look up individuals via any known identifier. Now, let's export this data. So we go into our individual record. What you may have noticed before is that we have data on Emil that spans from multiple different systems. We have information from social accounts. We have information that has come from, general mail. And if we go down here, you can see, for example, a time that Emil invited me to coffee over at Malmö. What's important is that we need an easy way to be able to export this data. And all it is a matter of in CluedIn is taking this ID, moving over to our GDPR API point, plugging in that ID, and pushing through a request. Now, you as the individual who requested that will get a nice email address to download this data. So let's download that. That's going to download email's export report. Now, it's important to identify that we need to export this data in an open data standard format, so this could possibly be sent on to other data controllers. Now, if we have a look at the data within this, essentially what we have is a full export into an open standard format that contains all the information that identifies or leads to the identification of Emil in one single place. Not only that, but we have all the origins of the data, who has access to it, if it's encrypted, i.e. checking all the 9 boxes that Nav and I have mentioned in this webinar. Now, it's also important that you export a report to Emil that he can understand in a very aesthetically easy to understand way. So let me show you what that looks like. I have an example report that we have right here. So let's have a look at a report which will be sent to Emil as an individual. Now, CluedIn builds this report and allows you to send this to the individual. We call this the personal data report, where not only do we give you an individual a breakdown of all the information that we have identifying this user, we break it down by the source, but we also give you a breakdown of the types of data, the consent and where it came from, and even individual links for that individual to look at the exact data that that company has on the individual. Now, why this is important, of course, is because the export is something that's not understandable by Emil, but the report is. The export is mainly for exporting in an open standard into other systems. So that's how we at CluedIn offer a solution for customers to be able to export and process a request within minutes instead of days. So Nav, I will give you back presenter mode, and so you can continue. There you go.
Great, Tim. Thank you so much. That was a great demonstration of CluedIn's technology. And just bear with me a moment while I replay this. And there we go. So I think that you know, I want to just highlight sort of what Tim said earlier there. I think we've been programmed over a period of time to basically grab any data that we can get a hold of on individuals and dump it in a data lake these days, and say, okay, now let's just grab the data. We'll think about, you know, how we're going to use it later. And I think that is what is now changed with GDPR. And Australia is planning to implement GDPR. India is thinking about it. In the US, it's called PII, not as stringent yet, but I think this is going to evolve. And I think one of the key areas is you need to be clear about how you're going to use the data. And I just wanted to highlight that point because I think that's so important. So what we have done is that you know, obviously there's a lot of, as you can see, complementary technology from Neo4j perspective. It's our core database engine, the graph database, and then also sort of the framework around that with the data model and you know, the integrations, and also visualization is a key aspect of GDPR reporting, because I think if you're able to visualize this data, especially able to show the subjects and the data protection authority in a visual way how all of this data is connected. You know, I talked about data lineage as an example. I think that's again a key differentiator from our perspective in the solution. And then of course CluedIn is bringing in you know, all the entity matching and you know, data deduplication aspects, and using machine learning to do that in a very effective and efficient way. So what we have put together here is a minimum viable solution. I think a lot of companies are struggling with this right now on what they need to put together by May that gets them past this regulation. And the way I have broken it up is that I refer to something called a static data and dynamic data. And by static data, I mean data that is infrequently changing, like you know, the applications or the systems that contain personally identifiable data. What locations are those applications or systems running at? Things like that, or for example, who are the users that can access a particular application. You know, these are pieces of data that don't change very frequently. You might add another application or a system maybe you know, 3 or 4 times a year at the most. You may add a location even more infrequently, and things like that. And a lot of organizations think that just having this type of static data and knowing, okay, yeah, we'll have an application that's running here that may potentially have personal information, or that, oh yeah, all of these people in my organization have access to, you know, John Doe's data. And that's good enough for GDPR, but that's not correct. That is not true. You also need dynamic data. Dynamic data refers to data that's changing almost on a daily basis. For example, you know, when data, personal data on a subject moves from one application to another application. That they became, they went from being a prospect to being a customer, or a different type of customer. So, like for example, in a banking situation, they were a savings and checking customer. Then they went to having a 401k account in the US, for example, or they went to having a brokerage account. So those are changes that make your data move from one application or one system to another system, and this happens. This is dynamic data, and this happens on almost a daily basis for different personal data. Is also when an employee within your organization accesses a personal data record in the context of the work that they're doing. That's again dynamic data that's happening on a regular basis, on a daily basis, and all of that also needs to be tracked, because ultimately, when you are trying to produce this data lineage of who accessed my data, when did my data get into this system, do you have the consent, what time and where was the consent provided? All of this becomes a combination of static and dynamic data. So just wanted to explain that and how we look at it. And then I've gone through and sort of taken each slice of this grid and separated it out from a static and dynamic data perspective. And I think this gives you a really clear view of how we look at the GDPR requirements and what need to be implemented. So I'm not going to go through all of this. You're going to get this when you have access to this slide deck, and I'll just sort of page through it. But the importance of static and dynamic data in the solution overall is a key differentiator from our perspective. And these are sort of the reporting requirements. Providing a view into the GDPR register for the data protection officer to respond quickly to regulator requests, and being able to provide them an interface to actually go and look at your data. I think Tim showed you a way to export the data, but also you can provide visualization on top of the data so that you really don't have to necessarily export it if you don't need to, if the demand is not for data export, but if they can get a view into the data and run their own ad hoc queries to look at and satisfy themselves that you have the right solution, and you're able to sort of look at individuals, you're able to look at how they came into the system, how their data is being used, and all of that. And providing a UI or a programmatic interface for subjects to view and alter the data, and provide and revoke consent, be able to transfer the data to a different provider, and things like that are very essential part of the reporting that is required, or the user interface that is required for this solution. So like I said, we've got a framework, we've got an architecture as well as part of that framework, so we have brought in the best complementary solutions from both Neo4j and CluedIn perspective to make this a real solution for you. Including all kind of enterprise features. So if you're looking for on-prem solution, this is what it would look like. And going back to, again, the connected data and visualization of data lineage is a key solution differentiator, because this is all about connected data, as I mentioned earlier. And being able to sort of providing data lineage capability is no easy task, because if you look at traditional technologies like an RDBMS, anytime you have more than 3 or 4 joins, you start getting into queries that on certain, depending on your underlying hardware, but in most cases, once you start going more than 3 hops and 3 joins, you start getting into really heavy performance problems. And sometimes as that increases, your results may not even return from that. So it's extremely difficult to show lineage in a tabular form also. So if you have rows and columns, for somebody to basically go and figure out, okay, where did the data originate, and trace it back through the rows and columns back to, you know, where it is being used and how it got there, is extremely difficult. Even if you can get the results out in a single query, additional technology. So this is where a graph database is really key to showing that in a visual way, and it's a millisecond query for us. So I think we take that complexity and make it really easy to query against. You know, if as you are adding additional applications, adding additional consents, adding additional usage, adding additional locations, all this is extremely easy to add schema elements into Neo4j, and this is not something that we need to rewrite code for, or rewrite and have downtime in the system, have a new release, and so forth. So this takes, you know, the time to deployment is really critical, and it takes away, you know, it really improves that time to deployment every time a change happens like that, which you would expect in a GDPR solution. As the regulations evolve, as you add more applications into your you know, GDPR system. So this is what a sample lineage. This is what sample lineage looks like. And by the way, this is extremely simple example where the green bubbles are really showing the actual time, or the actual movement when it happened, and the blue bubbles are the application. So RAB refers to you know, a bank and its system, account opening system, core systems, CRM systems, offer management systems, and so forth. So this is how the data traveled between these systems, and this is an example, a demo that we did earlier, but I think it gives you an idea of what this lineage may look like. And this is just using systems and for a particular person, but it doesn't include location, it doesn't include users, it doesn't include consent, specific consent for specific purposes. So if you add all that, this becomes a very complex entity. And this is what Neo4j specializes in, simplifying these complex relationships and visualizing those. So with that, we are at the end of the webinar. I really encourage you to complete the poll. I think we've got a really stellar response. I think Angelica was just texting me that we've got about 80% response. We'd like to make it 100%. So if you could just respond to that poll question. And then from a next steps perspective, we've got a white paper on GDPR that you can download at that location. And that goes through some of what we've shared today in a little more detail. And also, I'd be happy to discuss your GDPR initiative with you. If you want to just go to that neo4j.com/brownbag and put in your request. Be happy to you know, discuss your initiative, where you are with it, how to take it forward. Please do take advantage of that, and both Tim and I would be happy to help. So with that, Angelica, do we have any questions?
Yeah, thank you so much, Nav and Tim. That was a great presentation. We have a couple of minutes, so I'll try and squeeze in as many questions as possible. Thank you to those who participated. So I have one, I think this would be for Tim. So he's asking about security. So you're exporting from CluedIn, which goes to an email with a link to download. So really anybody who could access that email is on a path from its sender to the recipient. They could get that exported data. So how do you manage security with CluedIn?
Yeah, so with the export, the token that gets exported with that link, it's a one. You could think of it like Mission Impossible, how once you've taken the phone call, it blows up. So we have a one, that access token lasts for one export only. So that's how we kind of help out with that, without that email not being potentially leaked into other environments as well.
Great. And then the demo was built on fairly ideal presumptions. So all of the data is in the Neo4j database. So what would you do with a situation where you have several information systems, different vendors, architectures that are in daily use, and you have new data and edit flowing daily into those systems? Is there kind of a universal system which can feed into the Neo4j database real time, or how's that managed?
Yeah, so essentially our technology stack, although Neo4j is the primary data store that we rely on, there is a relational database there, there is a search index there, there is a columnar database, there is a distributed cache server, and there is a blob store, so it's quite a polyglot design. What this allows us to do is use the right database for the right job. It just so happens that Neo4j for a lot of that is the right job. And the way that we offer data to get into our system, it's in three different ways. First of all, we have our REST API. We have a standard model, what we call the Clue. It supports structured and unstructured data. And so it's a model, a generic model that kind of any system can bend its data into. And that's what we understand. That's the model that we understand. And that data can be entered in a classic HTTP post, so posting to our REST API endpoint, or it can actually be done through a stream as well, where we offer you essentially an endpoint where you can stream data in from potentially Apache Spark or other streaming services. It could be Azure Data Lake. We have a couple of customers using the Data Lake right now in Azure. So it goes without saying as well that you know, a lot of the platforms, the more modern platforms today, do support real time. Some call them webhooks, some call them push notifications. So as soon as the data goes into those tools, it's actually pushed over to us immediately as well. Not all tools are like that. You know, some of these kind of tools that have been around for, you know, good 15, 20 years, that's still the, you know, the standard polling mechanism that we go back and get the newest data every few minutes. But we do support streaming in our API. That's the best way to stream live data into our system. It does go without saying that we are not a real-time system, i.e. data that is streamed into us. It could be a few minutes before you see it within our platform. You can probably realize it's because we're trying to clean it, to validate it, to enrich it, to connect it in the graph, to run the entity reconciliation, to run other text processing techniques to, in the end, be extremely confident that if we are merging data between Tim Ward and Timothy Ward, that these are the same individuals.
Angelica, I'd just like to add to that. I just want to share this architecture picture back. So if you look at the bottom of that picture, these are all the specific systems any enterprise would have. I mean, this could be you know, mainframe systems. This could be, you know, databases, or they could be, you know, the SAPs and Oracles of the world. Or your own custom implementation for something. And the idea is that the static data would be batched together. When I talked about the static and dynamic data, so the static data would be batched together and ingested into Neo4j. And the more of the real-time information, the dynamic data would be coming in through a data buffering technique. So it could be a Kafka queue, it could be a Rabbit queue, something like that. That buffers that data back into Neo4j. And that's how we integrate the disparate systems back into the Neo4j store and graph it there. And then also, once you have a request to be forgotten, or your subject is asking for consent to be revoked for something specific. That's again a request that's flowing down from Neo4j back into those systems, and those systems then provide a script or an adapter or a connector that can go and ensure that that aspect is secure deleted from their systems.